So if you have, when you write down the formulas, I mean, when I work with people with trig, have you memorized the formulas? Like, you know, a sine, cos, you gotta memorize this. I mean, the more you can write them. Yep. I mean, I have people, when we do trig, just get them down on paper right away. Sine, opposite. I mean, the more you could write these, ladies, the better you'll remember. Sine, the opposite over hypotenuse. Cosine, adjacent side over hypotenuse. And then tangent, of course, is opposite over adjacent. You need to commit those little phrases. You need to memorize these because trig is all about those. All right, now looking at this trig, you could only use that when it's a right triangle, right? If it's not a right triangle like those other ones, you got to use the other trig formulas. But if it has a right angle in it, you're able to use trig. So here, I'll wait till here. I'll see you, sister. All right, so trig is all dependent on the angle that you're looking in on, you're coming in on, right? So if I want the specific of sine A, I'm going to start with just sine A. Because for this problem, they wanted 6 total. So I'm just going to start with 1. So it depends on, if I'm coming from this angle, that means this piece over here is the opposite. And means this side right here is the adjacent. The side right across from this right angle is always the hypotenuse. But this opposite side depends on the angle you're coming from. If you're coming from angle A, then this side's the opposite, this is the adjacent. But if you're coming from sine C, maybe from this one, then that changes it. Now that means if you're coming in from this angle, now this is the opposite side, and this is adjacent. Does that kind of make sense a little bit?
Yeah.
So a lot of people, they don't realize that, you know, depending on the angle you're coming in, that tells you the side opposite of it or adjacent of it. So you okay with that?
Yeah.
Sweet. Because I have people, they're like sine C, and they mistakenly think like this is the adjacent side or something like that. All right, sweet. So you're good with that? So they just need 6 total combos. So I just started with just the basic sine one and cosine. So I'm going to do sine A, cosine A, tangent A. And then I'm going to come in from angle C and do sine C, cosine C, and tangent C. And now it's going to be just up to me when I'm trying to find those pieces to know what angle I'm coming in and what parts of this triangle make up like the opposite adjacent. So if I'm doing sine A here, and make me stop and explain, from that angle, coming in from angle A, opposite would be this little A piece right here, and adjacent would be here. So sine would be opposite over this piece adjacent or of hypotenuse. So sine A would be the length of A over B. Because from sine A, from this angle, that piece A is the opposite side, and this piece B is the hypotenuse. So if I did cosine A, what pieces are cosine adjacent over hypotenuse for A? Because from A is opposite, B is hypotenuse, C is adjacent. So if I want to do cosine from A, I want to use the adjacent side, which is C, over that same hypotenuse B.
Yeah.
That makes sense?
Yeah.
Okay. And then what about tangent A? If you're coming from angle A, what sides would you put together to be opposite over adjacent?
Little A over little C.
Yep. All right, I'm going to stop right there because if you could understand this, you understand the majority of trig. You know what angle you're coming in from. you know that the angle you're coming in from changes the opposite adjacent. The hypotenuse is always the same. All right, what about coming in from angle C? So coming in from this angle, if I want to do sine first, now which is the side across from C? Yep, so that would be little c on top, because coming in from a different angle, now C is the opposite over the B hypotenuse. Does that make sense?
Yeah.
And then you get see how sine A was different, because sine A, the opposite side was little a over that same B. But from this angle, opposite side was C over B. All right, so it looks like you pretty much got a good grasp of that. So cosine C to keep us going, cosine C would just be A over B, and then tangent would be opposite over adjacent, so C over A. What do you think about that, Lee? Escape?
Yeah.
All right. Will you want me, because I just want to get a little feeling of how you are in your trig. Do you want me to jump ahead to specific problems, or do you want me just to keep going? Because these problems were definitely the harder ones on that third page. These were definitely more labor intensive. All right, well, let's just, have you tried this one?
Which one is this? He did that one with us in like class.
So are you okay with that? Because what he did was you count how many boxes down here, right?
Yeah.
6. So that means if I take this triangle and slice it in half, that makes this a right triangle now, right? So that makes this piece wouldn't be 6 down there. That's the total. So this little piece of your triangle here, this is 6. I'm sorry, 3. And then you could count 1, 2, 3, 4, 5, 6 to get this piece right here. And then you need to be professionals at the Pythagorean Theorem, right?
So he did it.
How did he do it?
You put wait. So you put like the line through the middle to create a right triangle. Is that why?
Yeah, because if I take this triangle and draw a line through the middle, since it's straight up and down, I'm able to count boxes just to get that length.
Okay.
And then this one down here, I'm able to just count boxes 3. Because this problem, it wants all the length. And the first step is, are you watching?
Yeah.
Do you want me to move on?
Oh no, sorry.
Do you understand this problem? Do you want to do something else? Because
Sorry.
you look like you're not watching. Are you?
Also spacing out.
Yeah, she's spacing.
Sorry.
I mean, I can move on because this problem, it wants the angles,
Yeah.
it wants the length, it wants the perimeter, it wants you to find the angle, so you're going to have to do like trig because it wants you to find angle A, B, C, which is this angle right here. All right, well, I'm just going to keep going on this problem to help you out. I don't know if he did it the same way, or if you want me to stop and do something else, I will. But to find this length right here, which is the length of all the other pieces, I'm using Pythagorean Theorem. C squared equals that 6 sides squared plus that 3. You need to be professional at Pythagorean Theorem. So that length, C squared, comes from 36 plus 9. C squared equals the square root of 45, I believe. I'm sorry, C squared just equals 36 plus 9. C squared equals 45. So I'm not sure if he told you, but to solve for C, you square root both sides. And what that does is just gives you C by itself, and it gives you the length of that piece, which is root 45, which if you square rooted that on your calculator, gives you the actual like decimal length to that piece. So you need to know how to square root for sure. You know the square root button. the second button, and then hit this. You have to get that symbol. Yep. And then type in your 45. And I get about 6.7. Yeah. What happened?
I think our teacher did this for all of us, and that's what I was always like doing that.
Yeah, because what he's doing is he
Really
jumps. Is this confusing?
Yeah.
All right, let me do that.
I was just wondering like how like.
I'll be.
Okay. Because that seems a lot easier
Well,
than
what he did is what you have to do to find those angles. So what he's doing first is using that inverse sine trig to find the angles. But then I bet eventually he had to do Pythagorean Theorem to find the perimeter. Because I'm kind of jumping ahead. What I did here was I'm finding the length of the sides to start to find the perimeter. And then the next question says, are the sides equal? And they're not, because this is 6.7, 6.7, and the bottom is 6, so they're not all equal.
Oh, okay.
But I'm going to jump straight ahead to yours.
Okay, sorry.
No, that's okay. I'm here to work with you. I'm here to serve you. All right, so I'm going to blow up a little part of that triangle I drew. It's a right triangle, so I'm able to use trig. They want you to find angle. This is C. Another part of my triangle. So that's the part of the triangles I have, right? It wants you to find angle ABC, which is this angle right here. And then it wants you to find angle CAB. Ooh, that's a weird one, CAB. Yeah, CAB, which is this angle right here. And I think what he did, since this is an isosceles triangle, once you find this angle, you know it's going to be equal to this angle. And I bet what he did was he added these up and took that away from 180 to find this one. But let's find the first one, which is angle ABC, which is this angle right here. All right, so for this triangle here, I broke it up. I know this is 3. I know this is 6. I'm trying to find this angle right here. So what can I use? What trig formula can I use that has, for this part of the triangle I'm dealing with, I have the hypotenuse, no, I have the opposite side here given, and I have the adjacent side given. So what trig formula has opposite and adjacent? Tangent, right? You see that? You don't want to use cosine because cosine would be. So that means you're going to set up like this, ladies. Tangent of that angle ABC, and I'm just going to call it angle B, is from the part 6 divided by 3. You see that?
Yeah.
And then to get this, you do a weird thing. You do inverse tangent. Tangent to the -1, and I'll show you how to do that. Because when you do the inverse tangent to this, it's kind of like math, where this and this cancel, and leaves you just B now, whatever the angle is. But now the trick is to use your calculator to do this, because on your calculator, you need to hit the inverse tangent button. I'll show you. Because it's above the tangent, the root, so you got to go second. Like that. You see that?
Yeah.
And then in that parenthesis, I'm going to put 6 divided by 3. And then close that parenthesis. So it's equal. and I'll crank out another one on the spot for you because you do a couple of those. You'll get them right. So if I do that, that gave me what, 63.43, is that right?
Yeah.
Degrees. So this angle right here is 63.43, which means, ladies, this is a special triangle. It's called isosceles, where these two pieces are equal length. So that means this angle right here is 63 too. So if you're asking on this problem, what's angle ABC? Angle ABC is 63.43 degrees. And then angle CAB, which is this one up here, I'm doing the trick where the three angles of a triangle always add up to be 180. So if I know this is 63 about, and this angle right here is 63 about, that missing angle has got to be what it takes to add up to be 180. So if I take 63.43 plus another 64 or 63.43, add them up and take that away from 180, it gives me about what that angle has to be, about 53 degrees. Because if I add 53.14 to those other angles, 63, it totals up to 180. Yeah?
Yeah.
Sure?
I wish my teacher explained it like that.
I know, but it helps. It helps get it a different way. But watch this, ladies. Watch this right now. I will help you right now. Do you have a spot on that paper to just draw a little triangle?
Yeah.
And then we'll move on to some other ones. Let's say this is 4. Let's make this 10. Let's make the hypotenuse about 50. When you're using those inverse formulas to find the angle, you never do it for this one, because that one's always given. That's 90 degrees, right? But you can do it for the others. So let me ask you this. If I give you, how about, let's give you all three lengths, give you choices. If I want to find angle A, let's erase it. So if I'm trying to find angle A, and I only have these pieces right here of this triangle, it forces you to know which trig formula you got to use. So from angle A, what pieces am I giving you here? Because I want you to find angle A. So from this angle, what am I giving you here? Yep, I'm giving you the opposite and the, yep. Which formula has opposite hypotenuse? Sine. So for you, if you were trying to find angle A with only these two pieces, you would be forced to use sine because that's the only one that gives you opposite and adjacent. So write this down real quick. And then that would give you a 4/15. And then remember what I told you to how to inverse. So I'm going to have you practice on your calculator. Do inverse sine. Like practice using the inverse sine button on your calculator and then type in those fractions. See what you get for that angle. Again, based on the pieces they give you, you got to know which formula to use. And then if you're doing an angle, you got to be able to use the inverse method.
18.46.
Yep. And with that angle, ladies, technically, you have everything you need to find the other angle. Because remember, this is a 90-degree triangle. So if I know this is 15.46 and this is 90, would you be able to do math without trig to find that angle?
Yeah.
Because you got to be able to do that, right? So know that all three angles equal 180. So if I take away those pieces, that's one way to get that angle. Looks like it's about, what'd you get? 180 minus 15.46 plus. So I get about 74.54. All right, let's use trig now. See if we could duplicate that. All right, coming in from angle B, ladies. What pieces did I give you on this triangle?
Wait, how'd you get the 74 points?
Because I'll tell you, all three angles, lady, in a triangle always add up to 180 degrees. So if we give you, this one's always given. As soon as you see that symbol, you know it's 90. And the math that you did because you were smart got you this 15 one right here. So technically what we did, we realized this angle B plus 15.46 plus 90 equals 180. So to find B, I think I added these two numbers up and then I subtracted that from 180. Okay?
Yes.
All right, now if you're coming in from B, what pieces of the triangle am I giving you dealing with B now? Because from A, the pieces I gave you, this 4 and 15, was the opposite and the hypotenuse. So what's from B? Yep. Do you see that? That is clutch. Because if you're coming from B and you're forced to deal with adjacent hypotenuse, which one is it?
I just need to memorize that in my head.
You do. You have to memorize it. And the only way to memorize it is write it. Sine, opposite hypotenuse. Cosine, opposite adjacent. Oh, no. Adjacent hypotenuse. And then tangent, opposite. You got to just write it.
Yeah.
Sakatoa helps?
Yeah,
Yep.
that helps me.
Yeah, for sure. Sakatoa?
What?
That sounds silly, but it does help. Sine, opposite of hypotenuse. Yeah. All right. So to find B, she realized I got to deal with cosine because I'm given the adjacent and the hypotenuse. So if I take those two pieces and write them adjacent over hypotenuse, now it gives me the fraction that I could inverse cosine. So that gives me inverse cosine 4 divided by 15. It should be close to 74. Yep, right on the nose. 74.53. Yeah. So you see how you could get that angle two ways? All right, and then on that same page, ladies, just one more little triangle one. How about one where you're using trig to actually find lengths? Let's do one of those. Let's say this is 23 degrees right here. Let's say this is x right here and y. Oops, let's not make that y. Make that x. Make this 10. All right, how about a trig one where you're using actual trig to find a length? I gotta make sure you know you guys. All right, here we go. I'm trying to find this length right here. I give you this angle. What pieces from this angle am I giving you to work with here? That's the trick. From this angle.
Opposite?
Yep.
It's not the adjacent.
Yes, ma'am. Good job. So which formula has you use opposite adjacent? Tangent.
Tangent?
Yep. Once you memorize it, you'll get it. So now what you do for this one, because I give you an angle, you write this, ladies, you would write tangent 23 equals that side x over 10. I gotta make sure you know how to solve one of these ones where they give you the angle. That other one we did, ladies, those are the ones where you have to find the angle.
Okay.
This one don't gotta do no inverse.
Okay.
Alright, to solve for one of these, ladies, once you know what angle you're coming from, which tells you which sine, cosine, tan to use, then of course you set up these two pieces the right way too. And then what you do is you technically, this is a ratio problem. So to solve this ratio for x, technically I could put this whole mess over 1 and then just crisscross multiply technically. So when I times this way, I just get 1x or just x. And then the other way when I times it gives me just the answer for x. That's kind of weird. But it's for algebra, when you have two ratios that are equal, you crisscross multiply them to set them equal. So if I multiply this way, it gives me x. This way on my calculator, I gotta hit tangent 23, close that parenthesis, and then times it by 10. So why don't you ladies try that there? Because if you do that right, that should give you about 4.24. So I did tangent 23 first, and then close that parenthesis, and then times 10. All right. Let's get back to the handout there. Thank you for letting me go over that with you, ladies. All right. Do you want to crank out this guy real fast? Let's do it. You ready? Okay, let's do it. So this one is just like the problem I gave you, ladies. It gives you this angle 60. It gives you this angle 50. It gives you this length 8, but it does not give you any of the other sides. Those are the sides that they want you to be able to find. And this problem you're going to do just like that last problem we did. So you can do this on your handout. You ready? Okay, so how about which piece do you want to find first, ladies? Do you want to find this length or this one down here? X or Y?
Does it matter?
Nope. Because eventually you're going to have to find all three. X. All right, so if I'm finding X, I could either come in from this angle right here, or I could come in from this angle right
So
here.
does it matter which one you come from?
It only matters in terms of the pieces that you're trying to use. Like if I'm trying to find X right here, I wouldn't, if I came in from 30, you could solve it, because if I'm coming in from 30, I have this piece right here and this. So coming from 30, ladies, what pieces am I giving you here to deal with from this angle? Yep, I would be given the adjacent side. Do that in red. And I would give you the hypotenuse, right? So you're like, okay, I want to come in from angle 30. I want to find X. You ladies, because you're smart, you're like, okay, from angle 30, that's the hypotenuse and the adjacent. Now, what formula has hypotenuse adjacent? Cosine. Got to memorize it. Yep. Again, memorize it. Sine. The more you can write it. Oppo over hypotenuse. Cosine. Adjacent. And then I'm abbreviating over hypotenuse. Tangent. I'm telling you, ladies, you have to write these like a trillion times. That's the only way you're going to ever memorize this. You can't, for this, you can never just look at your paper. This is something you need to physically do. I got my students, when they're doing trig, don't even look at paper, write these down on your paper right away. The more you write those, the more it helps you remember. Because from this angle, 30, for sure, I would be using cosine. What about if I was still trying to solve x and I was coming from angle 60, then what pieces am I giving you from 60? Yep, so from 60 you would be dealing with the oppo and the, so what formula has opposite and hypotenuse? Sine. So do you see how, depending on the angle you come in from, what formula it kind of forces you to use? Alright, so let's do x first, coming in from 30, is that okay? So that means I got the hypotenuse adjacent from 30, that means I gotta use cosine 30. My pen lets me write. And then you set the other fraction up, that hypotenuse adjacent, you put 8 over x. And this problem a little bit tougher to solve. Let me show you. So first of all, do you see how I got cosine 30 is 8 over x? Okay, this one you still solve kind of the same way. It's still a crisscross problem, but the only thing with this one is when I crisscross this way, I get a kind of a weird, I get x times cosine 30. And then when I times the other way, I get 8. So for this one, it's a little bit different than that other one where I just had to cross multiply and I was done. For this one, when I cross multiply, then I have to divide both sides by cosine 30. So maybe solving for x, maybe using cosine wasn't a good idea, but I could still solve it. That just gives me x equals, and then I use my calculator, I do 8 divided by cosine 30. That should give you about 9 point. And that makes sense because that is the hypotenuse. That 9.2 is longer than this 8, which it should. If you're like, what? I didn't want to, I could also, if I wanted to, I could have came in from 60, but that would force me to use sine 60 because coming in from 60, now that 8 is the opposite. Oh no, that'd be the same problem, right? So I'd have to multiply and then divide. Alright, so yeah. Either way, either angle you come in from, either cosine 30, cosine adjacent over hypotenuse, or coming in from 60, opposite over hypotenuse. Either way, ladies, this problem has you crisscross multiply and divide this 8 by sine 60. That's what you're doing to get this answer. All you're doing is taking that 8 and dividing it by sine 60. That should give you that same length. 8 divided by 9.2. All right. Can I slow down here a little bit? What am I doing that's confusing you? Because that just gave me this length and this length. Now I got to do it again and find this length down here. Before I do that, are you seeing how I got that 9.2?
Yeah.
Can I, on your paper, can you try one for me real fast?
Yeah.
If I gave you this on your paper and this was 10, and you're coming in from 30 up here, can you just do a real quick practice one? Can you solve for that x using that triangle? Because it would be the same cosine 30. So same kind of problem, coming in from angle 30. I'm dealing with the adjacent side I'm giving you and the hypotenuse. So that forces you to have to use cosine 30. And then you set that up as adjacent over hypotenuse. And now the trick is, it's one of those where that first one I gave you right here, this one was super easy because all you had to do was cross multiply and that was the answer there. But this one's a little harder. So based on this, I want you ladies try to get this answer for x because you need to know how to solve one. So this way, technically is cosine 30 times x. Remember when you go one way? X times this cosine 30 is cosine 30x, and then equal, then I crisscross this way, and that gives me 10. So to solve for that x on your calculator, technically you're dividing both sides by cosine 30. And that will get that x all by itself and give you the answer to this little extra problem I gave you just to practice. So 10 divided by cosine 30. So I got about 11.5. Get that?
Yes.
Okay, let's take that. All right, so we did, this is 9.2 you got on this one?
Yes.
All right, now ladies, we need to find this y one right here. So to find y, we're not, you could come in from 30 or 60, you choose, you tell me. Coming in from 60, you'd be dealing with this 8 over the y, or coming from 60, you could be dealing with this hypotenuse and this adjacent side if you want, or I could be coming from this 30, and to solve for this y, use one that has opposite over hypotenuse or opposite over adjacent. You see all those combinations that I'm seeing kind of? So if I'm coming from angle 60 right here, and I want to find y, which formula has this adjacent side in it to 60? Because if I'm coming from 60 and I want to solve for y, I got to make sure I use the trig formula that has this adjacent piece over this 8 right here. Or of course, adjacent over hypotenuse, doesn't matter. So what I'm going to do, just to get things going here, from 60, I'm going to use tangent, just because tangent 60 equals the opposite side, 8 over y. And then that's another one where you got to be able to crisscross, multiply, and solve. If I didn't use tan 60, if I used, I think it's, if I use cosine 60, that might have been an easier one. Then I could have used adjacent over the hypotenuse. And the beauty of doing that, ladies, using the cosine 60 is that one you would just crisscross multiply and be done right away. Where if you use tangent 60, you're going to have to divide 8 by tangent 60. Man, God, I wish I had more time, ladies, to just really go over this whole thing. Because I like trig. But no matter what, either using cosine 60, which is adjacent over the number I know now, hypotenuse, or tangent 60, opposite over adjacent, either way, I could solve for y. And I think if you do this correctly, cosine 60 times 9.2. I get y is about 4.6.
How'd you get the cosine of the tangent?
I can do either one. Yep. Because if you're looking,
Your final answer?
yep, 4.6. Because if I'm looking for this triangle, I have this side is 8, this side is 9.2. Maybe I don't really have time to blow it up and make it look nice. But either way, ladies, you should right now use your calculator. See if you could either get that 4.6 with this combo, where all you do is times these two, and then try this combo right here. Try to get that same 4.6. Because this one's harder. This one, you're going to have to end up dividing 8 by tan 60. So try both. That first one. This one just has you do cosine 60. So cosine 60, close the parenthesis, times it by 9.2. You got that one?
Yeah.
All right, now try this harder one. This one, you're going to do 8 is going to be ended up divided by tan 60. Now the trick though, again though, your sister has got a good grasp. She knows why this one you didn't have to do no division. You just y equals this. But this one you did have to divide. It's kind of tricky, huh? All right, let's move on. How about number 12, ladies? Okay, we got a little bit of time, right? Or do you want to jump ahead to the last page? A couple of those.
Sure.
This page right here, right?
Yes.
All right. These, when you have triangles, ladies, that do not have this right angle in it, you can't use just the basic trig. You got to use this dominatrix stuff. But still, though, don't be intimidated by this, ladies, because all this is A, it just represents the little length of a triangle. A, that's the angle. And these, even though these look like super brutal, kick your butt, it's just the same. B and A just represent the little parts of the triangle that was length B. This is length A, length C. So that's really all it is. So here we go. For 13, ladies, since this is a right triangle, I'm able to use all the trig I want to find each angle and then to find my length. So here we go. Are we ready? So to find, let's find the lengths. How about, let's see, what do I got here? I got 4 and 7. So how about, let's find this last length right here. Because this says B, they're going to call this little length B right here 4. So you put a 4 right there, Lee. This little length right here is going to be the A length. That's 7. For this one, to find your little C length right here, you're going to use the Pythagorean Theorem. So for this one, I know the bottom piece is 7. I know that top piece is 4. To find that C piece, I do it like this. C squared equals 4 squared plus 7 squared. So that gives you 16 plus 49. If I add that up, gives me C squared equals the square root of 65. Oh, I'm sorry. I jumped the gun ahead. that's just c squared equals 65. And then to solve that, that's when you square root it. And then you could right root 65, or you could square root it for real and see what that number is. Looks like about 8.06 or something. And then I'm not sure, is he having you round to 1 decimal place or 2 decimal, 3 decimal places? Do you know?
It's never specified.
Never specified? Most trig problems have you round to 3, but I'll just round to 1.
Okay.
So are you okay so far with that? My 3 lengths? Alright, now to find the angles, now let's trig it up. I have all my lengths, ladies. I have alright, so let's find which angle we want to find first. I know angle C. What's angle C, ladies? Yeah, so I got that one. And now to find angle A and B, I'm forced to use trig and know what parts I'm dealing with. So if I'm finding angle B, I have a 4 and I have a missing PC. So if I'm coming in from this angle right here, lady, what formula forces me to use a 4 opposite and a hypotenuse? Sine coming in from B, sine is the one to use because coming in from B, I have the opposite side given. I don't really want to use this side here because that wouldn't really get me anywhere because I'm trying to find this. So I want to use sine, which is opposite over what I'm looking for, hypotenuse. So that's half the trick to trig knowing what to use. So cosine of angle B equals those 2 pieces opposite. Oh, you know what? I did that wrong, ladies. For this one, since you're given those 2 pieces, you wouldn't want to use cosine. Sorry about that. So for this one, since I'm dealing with this 4 and 7, and I know this is 8.1, oh, I guess I could use that. I'm sorry. So let's go back to that. I'm confusing myself. So cosine B would be opposite over hypotenuse, right? And then you're going to have to inverse cosine that. Now I'll give you angle B. So inverse cosine 4 divided by 8.1 should give you about 60 degrees. About 60. Alright, now to find A, you have the choice. You could use tangent, you could use cosine, you could use sine, because I have all 3 lengths. So what do you want to do? Tangent, cosine. Let's use cosine then. How about cosine A now coming in from a different angle? Cosine A means now the adjacent side. Wait, did I do that first one wrong? Oh, I did. This one's not right. I think. Isn't cosine adjacent over hypotenuse?
Yes.
Oh yeah. Ooh, whoops, ladies. I need to speak this way. So if I was coming in from cosine B, it would really be 7 over 8.1. Whoops. So that means inverse cosine in this. And I bet that's about 30. Yeah, I was looking at it. I think that angle was too big. So if I do inverse cosine 7 divided by 8.1. That gives me about 30. Yep, so angle B is about 30. And then to find that missing angle, you could either add those two up and subtract away from 180 to get that missing angle. That's probably your easiest way to do it. I mean, you could do trig, but why do trig for this problem when all I could do is add 90 and 30 and take that away from 180? So the other one's 60. And now perimeter, they have you add all the lengths, which is 19.1. And now area, you could either use 1/2 base times height, or you could use this super gnarly formula to find the area. Let's show you how to use that super gnarly formula. All right, so to find my area according to this, I'm going to find S first. S I get by adding 7 and 4 and 8.1 and dividing by 2. That gives me my S value. All three sides added up divided by 2. So let's do that. So 7 plus 4 plus 8.1 equals 19.1 divided by 2. Gives me 9.55 about. So for a triangle, you could always do 1/2 base times height. So the easy way to do this one, ladies, is 1/2 times the base times the height, which is 1/2 of 28, which is 14. That's really how you do the area for one of these. For these ones coming next, you definitely want to use that gnarly formula. But let me show you how that gnarly formula gives you the same area of 14. Hopefully it does. Let me see. So using that formula, it's the square root. I put that S number right here. I open up a parenthesis. I put that S number in there again. But you can see that first little piece is S minus the A piece. And then this is all times. The other piece is that same S number, but subtracting the B piece. And then that third one comes from that same S number, but subtracting the C piece. And if you do this gnarly formula right, you should get the same answer as 14 over here. This is square root. And again, I would practice on your calculator getting this, because test it, you're going to have to. So square root of 9.55 in parentheses, and then open up another parenthesis, 9.55 minus 7. Open up another parenthesis, 9.55 minus 4. And then one more parenthesis, 9.55 minus 8.1. And that didn't give me 14, so let me try that again. Maybe I got to do, let me show you the buttons I'm pressing. Oh, that's not going to work. So I think I got to do square root button, and then you got to hit double parentheses in there, I think. So let's try that again. So square root button, double parentheses, put 9.55 in there. So that's what I started typing.
Oh.
So I started typing.
Okay.
And then I'm going to, next to that, I'm going to do all the other parentheses. That's this one, 9.55 minus 7. Another 9.55 minus 4. close double parentheses. Yep, that gave me 13.99, which is 14. Double parentheses. This one is the other way. So we can clear this one. Oh, what's that?
Wait, so double.
So square root, double parentheses, hit 9.55, close that one parenthesis, and then open up one, and do the 9.55, minus 7, close it, open another one, 9.55, minus 4, close it, open another one, 9.55, minus 8.1, and then 2, close parentheses. So that's about 14. But realistically, no one in their right mind would ever use that.
Yeah.
That one is used, ladies, for these two. Because these two, you can't use a simple formula, a half-time bit, you gotta use that nasty formula. Alright, I'll keep going. Let's keep going. And then, what I'll do, ladies, for you, I think if you leave here, I'll try to finish this page up in this video and send it to you. Because I think we're gonna run out of time here.
Yeah.
Alright, but we could at least do 14, right? So real quick, 14. So 14, you're forced to use now this formula because you can't use simple sine, cosine, tangent. So for this one, this is gnarly. I think this is 124, right? Is that 124?
Yes.
So I'm gonna say from that 124, I gotta start using this formula up here. So I'm gonna say, or this one, doesn't matter. If I say sine 124, sine of this over b, let's see how I did this. Sine of 124. Is this a number right here?
That's a B.
That's a b.
Yeah.
Equals. Let's see how did I do this one. So I did sine 24 over b is equal to sine c over 2. God, what did I do? Let's see. Oh, you know what, ladies? For this one, I was forced to use this one right here. I remember. There we go. All right, so for this one, I'm forced to use, and I think what I did, ladies, was use this one right here. Because when I was looking at it, I have B. I'm looking for the B part. I'm trying to solve for B. That's why I use this one. That's solving for B. I have the A piece. I have the C piece. I have the AC piece. And I have this angle B. Holy moly. So what I'm going to do, I'm going to use that one I circled. Let me show you how I use that. So all I do is I plug it in. I'm solving for that b right there by writing b squared. For a squared, I know a is 15, so I put 15 squared for a. And then I know c squared, c for this one, is 20. 20 squared. And then I minus 2 times a, c again. So a and c are 15 and 20. And then, of course, I do cosine of that. Is that 124 right there? And then once I get that big old mess, then I have to square root that to get b. So what I did on this one, I think, to make my life easy, I think what I did to solve for b on this one, I just square rooted this whole mess right away to get just what that b length is. So again, this is something gotta practice. I gotta be able to do this on a calculator. That is a big square root symbol, and then 15 squared plus 20 squared minus 2, and then I'll use parentheses, parenthesis 15, another parenthesis times 20, and then another parenthesis cosine 124. And if you do that right, you get about 30.9. That is a mess. Holy moly. And again, it just takes practice. So I did second square root, 15 squared plus 20 squared. Did you get about 30.9?
Yeah.
Alright, so for your lengths, A is 15 right here, ladies. B, we just did our work to get 30.9. And then C is 20. Alright, now what I did, I know angle B is 124. I used now this guy to find my other angles. So what I did, to find this angle right here, I did sine 124 over 39, sine 124 over this piece. By this definition, sine A over piece A equals, that was B. We'll go sine A over 50. Because again, I'm using this formula here, where by definition, the sine of a angle over that piece, sine of this over this piece, is equal to the sine of this one over this piece. And then technically to solve this one, you're going to do a big mess. You're going to have to multiply this way, and then you're going to have to inverse sine it. So one way when I times it, I get 15 times sine 124. The other way, when I do it, I get 30.9 times sine A. So for this one, I gotta divide by 30.9. And then I'm gonna inverse sine this whole madness piece right here. So that gives me, when I'm solving that, let's shrink this down. That gives me sine A equals that whole big old mess. And now you have to inverse sine that one. And that gives me angle A. Holy crap, this is fantastic. So 15, so inverse sine, and then try to type that in. 15 times sine 124. But I gotta make sure I divide that. So maybe inverse sine, double parenthesis, 15 times sine 124. Close that parenthesis, divided by 30.9. I get 23.7. So all that madness, now I have angle A is 23.7. And now to find angle C, I wouldn't encourage doing that again. I would just take 23.7 plus that 124 and take that away from 180. So it's about 32. Perimeter, you would just add up those pieces. But area for that one, you're going to be forced to use the big old gnarly area formula problem that we did. So let me try to shrink that down. What do you think, ladies? You guys gotta go? You gotta go?
Yeah.
Okay.
That's a lot.
It's a lot. And you know, when we did this part right here, ladies, that was super important for you to understand it. But these just take it a step further. I mean, for this one, you could do all those formulas. But these two, which I'll try to make a nice video for you ladies, showing you these two right here. These are where you're really earning your money. And then if you can master these calculators, you have to, because there's no way you could do this by hand without a calculator. And even with a calculator,
Get confused with all the parentheses.
yes, all the parentheses, because if you, when I was doing this, some of those where I didn't put a double parenthesis in there, it wasn't working.
Thank you.
You're welcome, ladies. I wish I could work with you every day, because I guarantee you I would teach you ladies. You would ace this stuff, I promise.
I actually know I'm doing it now.
But just sometimes it takes a different teacher's perspective to show you a different way.
Yeah. I wish my teacher taught like this.
But just know you ladies got it in you.
Thank
See you later. See you tomorrow. Or today. See you later.